All right, here we go. Unit 6 review. Let's kind of make sure we're good to go on everything from this section, or I'm sorry, this whole unit before the test here. Oh, excuse me. Sorry about that. All right, so what is similar? Remember, similar means that we're talking about it has the exact same shape, but what's the only thing is a different size. So same shape, different size. So that is similar. And I know a lot of time in this chapter we spent on triangles. It doesn't have to be triangles. We could have like a little trapezoid looking thing, and then maybe I've got one that's smaller. So they're the same shape, different size. Or I could have one that's even bigger if you wanted. Same shape, different size. Fantastic. So that leads us to scale factor. Scale factor is like this proportionality constant. How much bigger is it? So I don't know if I used that word before, proportionality constant, but it's like how much bigger or smaller is something. Is it twice as big, three times as big, 1.5 times as big? So we're looking at this idea of how much, what's the proportionality here. So if I have an example like this, these two figures are similar. I want to name them. What I do is I've got triangle JKL, so I go in order. JK, so here's JK. JK, everybody. JK is 32. I look at 32. 32 is the smallest side, so it's got to match the small side over here, which is 24. So it's got to match GF. So they're the corresponding sides. They're similar. They should be proportional. Then from there, I know if it goes to J to K to L, this has got to go from G to F to E. So I can fill that in. But let's make sure we know the corresponding parts match up. The next one is from K to L. Look at this is 56. It's the biggest side, so it's got to match F to E. So they're proportional. And then the last one is I go up here at the middle side, 52. 39 is the middle side over here. So they're all proportional. So if you take any of those, 32 is to 24. That would be the scale factor. That works, which is the same as 32 matches when red is to red. 56 is to 42. That matches. And the last one, 52, matches 39. So if I made these decimals, they would all be the same decimal, all the same scale factor. So they would all be the same. Could you flip them upside down? Sure. You could go from big to small, or small to biggie smalls, or small to big. You could flip them all. You could say 24 is to 32, or 42 is to 56, is the same thing as 39 is to 52. So either one of these will be right. You know, if you tell me on the test, oh yeah, the scale factor is this, you know, that's right. You can say that the big triangle is 1.333333 times bigger, or if you tell me the opposite, this is also right. You could say, oh, that's not right. That would actually be wrong. Let's try it again. 24 divided by 32 is 0.75. You could say the small one's 0.75 of the big one. So either way works out. And again, they all match up. You know, 0.75, 42 over 56 has got to be 0.75. And 39 over 52, again, got to be... Oh, why do I keep doing it? I'm having some issues. 39 divided by 52 is got to be 0.75. Fantastic. All right, so that's really the first section in a nutshell. Then we went on to say, okay, can we prove it without showing every single thing? Are there shortcuts to prove that, yes, they are? Here's one right here. This is angle similarity. I know that these two are similar. Why? Because I know a bunch of angles. Really, I know vertical angles here are congruent. And I know that these are parallel, so you've got corresponding angles. This is this. You only need two. In this case, I could actually show the third one is, but all you need is two to show they're similar. So this is the angle similarity, because if these two are the same, the third angle's got to match up. So if you can find two angles that are the same, these are definitely similar. And again, just make sure you're naming it correctly. From F to G is this way, so it's got to match which one? This way. So it's got to match F to C to D. So you do have to label that correctly so the corresponding parts match up. How about this one? Hopefully this is side. I've got all the sides. So I'm looking at, is this side similarity? Well, again, we kind of just did this in the last one. Start matching them up. I start with the small one. 42, who's the small one over here? Kind of maybe a little hard to see, is this one. So I'm going to say 42 is to 49 must be the same thing as what? It must be, here's the medium side, 48 to 56, medium side. So 48 is to 56. And that must match which one? The last side, big side. 60 is to 70. So if all these are the same, they all have to work. So now we have to check them. Last time I told you it was similar, so I knew it was going to work out. Here I'm not real sure. Are they similar? So we've got 42 is to 49. They're crazy scale factor. Is that the same as 48 to 56? It is. Is that the same as 60 is to 70? It is, so I know I'm good to go. These are all the same, so I checked them. So I'm good to go on that. So those are all the same. So yes, it's similar by side, side, side. And then make sure we name it correctly. I've got this nice and color coded. So it went VU, that matches which one? VUT would be the same as JKL. Triangle JKL. Awesome. Fantastic. And the last one, what is this? Well, I know that this angle is congruent to this angle because they're vertical angles. So I'm looking at side, angle, side. So is it side, angle, side, similarity? These are the three ways, by the way, we can prove angle, angle, similarity, side, 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 similarity, and side, angle, side, similarity. If you don't have that, then we can't use a shortcut to prove it. But again, you have to check your sides here. I know the angle's good, but you have to check it. So be careful here. Again, I look at small side. 27 is the small side. 9 is the small one over here. So I'm looking at, is 27 over 9 the same thing as what? 33 matches 11. So you got to line them up, 33 to 11. And let's just check that real quick, make sure that it all works out. Wait a minute, I know 27 divided by 9. What am I doing? Is 3, and then I also know this, but since I got the calculator up, I'm just going to finish it out. What was that? 33 divided by 11? Unbelievable. Mr. Brush using a calculator for that. That's all right, as long as you get it right. So there it is, 3. So this is 3 times bigger than that one. So yes, this one does work out by side, angle, side. So go ahead and let's fill this in. Triangle FED, it goes from F to E to D. So I'm going to go from F to T to U. Awesome. Fantastic. So that was 6.2. The final one is the side splitter theorem. Remember, everything here is essentially proportional. So this side matches this side matches this side, and the whole side matches the whole side. So all these are proportional. So you got all kinds of options here. Let's set this up. What are we going to do for this? We're going to say, well, the whole thing is 6, so if that's 4, what's left over? It's got to be 2. 4 plus 2 is 6. So I can say, yeah, 3 is to 2. This side is to this side as what? This question mark side is to this side right here. So question mark, I'm going to use x. And then it's just a matter of, can you cross multiply and solve that? So can I do it? Sure. 4 times 3 is 12. 2x. X has got to be 6. So I can find x, no problem. X is 6. Fantastic. Can you do it when there's an x in it? Yeah, same idea. So if that's 15 and 6, what's left over? That's 9. Just subtract them. And then these sides match up. So I'm going to say 9 is to 2x minus 8. And that's got to be proportional to 6 is to 8. And again, just be careful when you distribute on these. 8 times 9, no problem. That's 72. But be careful on this when you cross multiply. This is 6 times 2x minus 8. So you got to put that in parentheses and solve that. Let's just finish it out. Give us a little closure here. So 72 equals 12x minus 6 times 8, 48. So if you add 48 to both sides, you should get what? 120 equals 12x. And then divide them out. That should be 10. And I'm good to go. And you can plug it back in. Does it make sense? 2 times 10 minus 8. Sure, that's 20 minus 8, 12. So it looks pretty good. 6 is the 9, as 8 is the 12. Fantastic. All right, one more slide and we're done for the review. This was like a little corollary to the side splitter theorem. So we've got these parallel lines going on here. Same idea though, we have, this one's interesting. So if this is 4 and 12, we know this has got to be 8. So what we can say this is to this. So 10 is to 8. We got that going on. But what else do we know? It's true that this part is this part, but I can't tell you this part because I don't know the whole thing. So I'm kind of stuck there. So we have to go to the whole thing. The whole thing is to the whole thing. So that's cool. That works out. So the whole thing over here I don't know is x. And then the whole thing over here is 12. Then cross multiply and solve. 8x equals 120. So how many times does 8 go in that? It should go in there 15 times. Didn't need a calculator for that one. Awesome. Let's set the last one here to make sure we are good to go. So we've got 2 and 6. So I know this is 4. I don't know if I need it. Again, I can't find that side. So I'm going to say 6 is to 4. They match up as what? Then on the outside here, I've got this one is to this one. So I'm looking at negative 5 plus 2x is to 6. So same style problem. Again, when you cross multiply, just be careful with this because we want to make sure we get that distribution in. So we've got 4 times negative 5 plus 2x. And distribute that bad boy. We're looking at negative 20 when I distribute this. And 4 times 2x, 8x. Add 20 both sides. 56 equals 8x divided by 8. 7. Killed it. Nailed it. There it is. I hope you blow up this test. Good luck. Peace out.